Right, hello everyone and welcome. Really delighted to be able to share with you the new data model enhancements. I'd just like to see a quick show of hands. How many of you learned about the data model for the first time in Devs on Stage this morning? Wow, amazing. Really glad to see you've turned out to this session where we're going to take what Tyler showed in about 10 minutes and unpack that over the course of an hour. So second question, how many of you had a lot of questions during the presentation? Okay, good. I'm going to ask at the end and see if I've answered some of those questions for you guys. So my name's Bethany. I'm a product manager for the data model. Before joining this team, I was working in our consulting team for 6 years in London, and I spent about 6 years sending relentless product feedback emails about data blending, and that was how the London product management team was born. So excited to show you a bit more about what we've built, and it's in pre-release today. So as we're going through, if you're feeling really excited, you want to try it on your own data, you can download it immediately following the session. So let's get started. Now, just to frame a little bit, what are we talking about with this new data model? It's really about combining multiple tables of data, quite simply, which is a fundamental task of analysis. And a common perception that people have of combining tables of data is that it's just easy. You just take the two slices of bread and put them together. It should just work, right? But for those of you who have been working in this area, you'll be aware that it's a little bit more nuanced. It's a little bit more like making a French pastry where the assembly is actually the easiest part. So in terms of the agenda that we're going to go through today, I'm going to start off by just taking you through a concept overview about how joins work, so independently of Tableau. And then once we've gone through the concept of joins, we're going to talk about how that's implemented in Tableau, both today and with the data model enhancements. So today we have joins and blends, and with the new data model, we're adding relationships. So I'll talk you through the similarities and differences between those. And then we're going to go into the pre-release build, and I'll spend about 40 minutes taking you through in detail what this really means and how it's going to change the experience for the better. All right. So if we just review what is a join. At the most basic level, a join takes two input tables, combines them to output a third table. Now, there are different types of joins that are required based on the structure of your tables. There are row-level joins, and there are aggregate joins. So with row-level joins, we take every row in one table and join it to every row in the other table. So let's take a look at an example of a row-level join. So I have two tables, an events table and a state table. So in the events table, there's one row for every event and a description of the type of event and where it's happening. And then in my state table, I have population. So I want to join these on state. So what it's going to do is go and look up the matching value in this table and then append that population column. And so the third output table that's created from this join adds population as a column to the table. Now, this can be problematic for performing analysis on this type of table. What a lot of your analysis does is it aggregates the data. And so if you were to take a sum of population on this table, it's going to tell you that there's 160 million people in California. And so this structure of table turns out to be not that useful, or it can create challenges in analysis. And so in that scenario, the tables that you're joining may need to be aggregated to a common level before actually combining them. So in this case, we would take that more granular table, aggregate it to a common level of detail, and then join the result of the aggregate table. So let me show you again, what does that concept look like on the events example. So in this case, rather than just straight away joining the tables, I want to create one row per state in my events table. So the way to do that is to aggregate this up and count the number of events per state. And so now, if I join these two tables on the state, I'm getting this nice table here where the population of California is 40 million. It's not being replicated, and so I don't need to worry about that population number being double counted. Now, there's different types of analysis that you may want to do on these tables. And so different questions require aggregating the data to different levels of detail. So another case may be that you want to see the number of events per capita by each event type. And so in that case, if the previous aggregation would remove the event type. So to be able to join those tables, I'd want to aggregate this by state and by event, with a count of the number of events for each combination of states and event types. And so now, if I were to join both of these tables together, it's going to now give this table where, when you do analysis on this, it'll tell you that there's one event per 20 million people for each of the event types and states. All right, so there's one really fundamental concept that I want to get across with this example here that's going to drive a lot of the changes that you're going to see with Tableau's data model enhancements. With row-level joins, there is only one way to perform the row-level join. You take every row in this table and every row in this table and match them up. And so what that means is that a row-level join is producing a fixed output. With aggregate joins, as you've just seen with those two different types of aggregations, there's many different ways that you can aggregate the data, which means that the output table you're producing from an aggregate join is variable. Lots of pictures being taken. Okay, so what does this mean for Tableau, and how is this implemented in Tableau today with joins and blends and data sources? So just a bit of terminology that we're going to use going forward in Tableau's data model documentation. So we have the input tables to your join as they are stored in your database or in your Excel files are what we call the physical tables. It's the actual structure of the data as it's stored on disk. And when you join those, this resulting table is a logical table. It doesn't actually get stored up front unless you persist it somewhere. And so in Tableau today, when you create a data source, you can join as many tables as you want, but the end result is one single logical table. Now, if you want to then combine multiple of those logical tables, which may be at different levels of detail, that type of aggregate join is accomplished with data blending. And so in that case, we would take two of these data sources, two of these separate logical tables. When you blend them, the whole reason we have this concept of primary and secondary data source is the secondary gets aggregated into the primary data source. And then the resulting output of that data blend is a Tableau visualization. So that's joins produce data sources, blends produce visualizations, and now we're introducing a third concept, which is going to expand what we call a data source in Tableau today. So if you take one of these logical tables, and we're going to allow you to combine multiple of these logical tables in a single data source. And the way that you will combine those, because they often require aggregate joins, is through relationships. And that's the noodle that Tyler shared with you this morning in Devs on Stage. So this means now a data source can contain multiple different tables at different levels of detail. So let me go through how these relationships are new and different from blends versus joins. I should have also added here that the logical table can be made up of as many physical tables as you want. So with joins versus relationships, the most fundamental difference is the level of detail of the join. So with joins, we're always doing row-level joins. With relationships, we'll be aggregating the tables to the level of the related field and then performing the join. The input to a join is our physical tables, and the resulting output that's produced from that join is a logical table. With relationships, they relate logical tables, and the output isn't anything fixed. Remember that aggregate joins produce variable output, so you cannot preview the relationship. A relationship is creating a definition for how to query the tables when they're used in combination with each other. With joins, you have to specify the join type up front. So whether it's a left join, an inner join, an outer join. With relationships, that concept no longer exists because the join type is determined on the fly based on the context of measures and dimensions and tables in your visualization. However, that said, you can still set it to give you an inner join if you choose. We'll get into that in more detail in the demo. In terms of the queries, a join is executed as part of every single query. So if you create a data source today that has 20 different tables joined together, Tableau will join, every visualization will join all 20 tables all of the time, which with live connections can cause some challenges with performance. With relationships, we only join the tables that are required in the visualization. So if you create a model with 20 tables and only use 2, only those 2 tables will be joined in your visualization. In terms of extracts, so an extract is when you take your logical table and persist and store it, the result. And since joins produced a fixed output, a join can be extracted. Since relationships do not produce a fixed output, you cannot persist the result or store it in an extract. But that said, you can still create extracts from tables that have multiple, that have relationships. We will extract each logical table in a multi-table extract. All right, let's talk about blends. Who uses data blending? Who tries to avoid data blending? Yes. All right. So blends and relationships are both similar in the sense that they are aggregate joins. However, there are a number of differences between them. In terms of the scope, your blends are set on a per worksheet basis, whereas with relationships, it's defined in the data source level. And so that has some really significant implications for sharing. Since blends are part of the worksheet, you cannot publish a blend. But since relationships are part of the data source, you can publish a relationship for other people to use. In terms of the semantics, blending has a primary and a secondary data source. And the secondary data source is very much a second-class citizen. With relationships, all of the tables are equal. And so some of the limitations you may have encountered with blending, where you can't use LOD expressions or count distincts or so on, like all of those go away with relationships. In terms of your join type, blending is always a left join to the primary data source. With relationships, we can do all join types are supported. So you can do full outer joins now across in combination with aggregate joins. In terms of performance, blending, if you're linking on something very granular like a customer ID, you've probably encountered some performance challenges because the blend is locally computed. With relationships, we are executing all of the joins as part of the database query. And that's one of the reasons why relationships are removing so many of the limitations that you've encountered with blending being kind of a post-aggregate function. With blending, the related fields between your data sources are variables, so you turn on and off links on a per worksheet basis. With relationships, you define the relationship once up front, and that's carried through to everything that uses that sheet. And finally, in terms of data models, blends only allow you to relate tables that directly share a related field. With relationships, you may want to combine two tables that are only related to each other through like 5 other tables. And so you can traverse an infinite number of tables to connect your related logical tables. All right, who's excited? Yes! All right, so I'm going to get into the demo right away, but just before, I want to take you through a challenge you may have encountered with row-level joins today, just to make it really concrete. So I'm using the exact same data source that Tyler used in Devs on Stage this morning, sales opportunities. So a sales opportunity is the potential for a future order. If you're selling an industrial product or a high-tech product, it can have a long sales cycle. And it may and because the products are quite complex, it may not be known up front what product the customer needs to buy. And so I'm joining here opportunities and then the opportunity products. But because it may not be known what product they need up front, there are many opportunities with no products. And so I've set this to an inner join to keep just the opportunities that have products. All right, so here's our total opportunity amount is 13 million. And so that, you'll see here, is coming from the opportunity table. Additionally, I have in the products table, the more granular line item table, I have the quantity of each product and the price, the unit price. And so if all is well in the world, the total opportunity amount should be equal to the quantity multiplied by the sales price. Uh-oh, how do I reset this? There we go. Okay, so let's go and check. So I'm going to do a type-in calc here to just multiply the quantity times the sales price. And sure enough, they're not equal. So what is happening here? Well, let me bring in the opportunity ID. And then let me just filter this down to keep just one opportunity. And then let's break this down by product. And so what you see here is that the total opportunity amount is being replicated across the product line items, which means that your total opportunity amount will be multiplied by the number of products that are on the opportunity. And so to fix this in Tableau today, in a flat table model, you would need a level of detail expression to say, just aggregate this opportunity amount here to the opportunity level of detail with a minimum or a maximum or something that is not a sum. And so then if we take that level of detail expression, that ends up giving this correct aggregation that you would expect to see. So in the new data model, you never need to do this ever again. All right, so let's take a look. And whoops. Let me go and connect to a new data source here. All right, so I'm going to drag in the opportunity table as its own standalone logical table. And now I'm going to relate that in. Get ready for it, the noodle is coming. I'm going to relate that in with the opportunity products. And so you'll see here, as I click on the table, and it's updating the data grid, it's keeping each table separate. And it's automatically identified the relationship here, similar to joins, which you can add to or edit as required. But one important point to note here in this relationship editor is that it's not asking anywhere for me to configure the join type because that concept doesn't exist with relationships. With relationships, you can think of it like a contract, where we're saying, hey, Tableau, if you were to join these two tables, this is the way in which you would join them, and it then defers that join decision to analysis time. So let's take a look at our level of detail challenge on this data model. So I'm going to multiply again the quantity times the sales price. And so hopefully this should match the total opportunity amount. Let me drag that in. And they still don't match. But in this case, they don't match for very different reasons than the row-level join. Recall that not all opportunities have products. In this case, we're always keeping all of your measures. And so if I grab this field here in the opportunities table that indicates if it has a line item or not, let's split that up. And so now you can see that for the opportunities with line items, it is automatically aggregating the data to the correct level of detail with no LOD expressions. And it's also retained this $10 million of opportunities that don't have any products. Now, if you're managing a sales process, that number is very interesting. While joins can evaporate $10 million into nowhere, with relationships, we'll always keep all of your measure values. Now, I just want to draw your attention for a moment to the schema viewer over here. So you'll notice here that things look a little bit different. We're now grouping fields by table and then breaking down by measures and dimensions within each table. And so if I go and take this ad hoc calculation I just created and drag it into the schema viewer, you'll see that it lands inside the opportunity products table. And that's because it knows that that is the level of detail of that calculation. Now, some of you may be wondering, how could you achieve this analysis here if you don't have that line items flag pre-calculated in your table? Be not afraid. You can calculate this in Tableau today. So let me go and pretend we didn't have that. So the way that we would calculate that is for each opportunity ID, let me zoom in here. Oh, no. Let me zoom in here. So for each opportunity ID, we need to count the number of products on that opportunity. And if it's greater than one or more, it means that it has line items. And so we can do that analysis through a set. So let me go and create a set here and add a condition that the count of opportunity products, you'll notice here there's this new table icon. That tells you we're counting the number of records in that table. And so if I count that greater than 0, this is going to be the ops with line items. And so now you'll notice as well that this set is no longer being put at the bottom of the schema viewer. It's being grouped with its table that it originates from. And so if I drop this now on filters, bam, we're getting the matching opportunities from both tables. Now, what I've just done there by dragging that set to filters is giving the equivalent behavior as if you had created an inner join. And so what we're doing with the new data model is deferring that join type decision to analysis time so that you can have all different join types on one single data source. Why constrain you up front? Now, let's go and, yes, right. So far up until this point, I've been trying to get these numbers to be equal to each other. However, they still mean different things because they come from tables at different levels of detail. And taking the same measure at different levels of detail and relating it allows you to do a lot of new and interesting types of analysis very easily. So let me go and grab products and break this down by product. Now you'll see that the results here are quite different from both sides. And it's because these numbers mean different things when broken down by product. So the quantity times the sales price here is telling you that there was $500,000 of revenue from control boards. Whereas this is telling you that there was $1.8 million of revenue from opportunities that sell control boards. And so that's interesting because that lets you see that about a quarter of your revenue for that, a quarter of your revenue from opportunities that have control boards come from the product itself. And so it needs to be sold alongside other things. Now, you may be wondering, could we have done this? Oh yes, another interesting point with this is that while this is causing measure replication because the same opportunity is counted across multiple products, it does not cause measure replication when we go and turn on the grand totals. And so here you can see that we're still aggregating the total to its correct level of detail rather than just giving you the sum of the bars. And so it's always able to recognize what's the right level of detail for that measure. Yes! So let me just compare this to joins for a moment. So you may be wondering, is the same analysis possible if we had joined these tables together? And it is indeed. So if you look at control boards here, you'll see that we're getting the exact same numbers for both of these measures. And I'll just point out as well here, you can tell that these tables are joined from the schema viewer, where all the dimensions are together and all of the measures are grouped together at the bottom, rather than splitting out by table. But now, in this joined data source, watch what happens when I turn on the totals. In this case, it is replicating the total opportunity amount because it doesn't understand the level of detail of that measure. And so while this analysis was possible with joins, it was the only thing you could create on that data source because any other types of analysis that you would do on that data source would cause this measure replication problem. So let me just go through and summarize what we've seen so far in the demo. So first, and perhaps most exciting, is the automatic level of detail aggregation, which allows you to do interesting analysis without LOD, any more LOD expressions to correct your measure aggregations. Another huge benefit is that we will always show you your unmatched measures. And so while joins can just evaporate money into the middle of nowhere without you being aware, with relationships, we're always going to show you the unmatched measure values. However, if you don't want to see the unmatched measure values, you can create the equivalent of an inner join and set the join type through filtering operations. And finally, with the new data model, we're allowing you to have more general purpose data sources. So while previously certain types of analysis required their own custom bespoke data source to do just that one thing, you can now achieve that analysis on a normal Tableau data source. Are we excited? Yes. All right, so at this point, you may be feeling a combination of excitement and anxiety, which is a perfectly normal reaction. Particularly anxiety at this point here, that the join type is set through filters. You may be wondering, do I really have to do that every single time? But you do not, because with the new data model, we're not taking away anything that you can do today. So joins are still possible. Now let me go and show you how that works. So here we're looking at the opportunities table. And you'll see that we have this column for the owner ID. So what that column is it indicates who the salesperson for the opportunity is. And you can look that up in this user table. Now the user table contains lots of different types of people. Salespeople are one type of person, but it also has administrators, tech support, and even Francois. And so we may want to exclude Francois from this table because he is not a salesperson. And so in that case, what I really want is to just append the name of the person as a column in my opportunities table. And I can do that through a join. So right now, we're looking at the logical table. But if I double-click on this table, or select Open in the context menu, it now transitions into the prep experience that you know today. Yes! So here, you can use joins, unions, custom SQL, all the pivots, all the things you know today in order to define the physical structure of that table. And so if I bring in now users, I'm going to set this to relate them on owner ID is equal to user ID, and I can set that as a left join. And so now as I update the resulting table in the data grid, you can see that the name of the salesperson has now been appended as a column to that table. Let's transition back out of this. Now, another table that I'm missing from this data source, I've added in the salesperson, but I don't yet know who the opportunity is with. And this is a business-to-business sales process, and so the customers in this case are companies. And so I'm going to grab the company table and then relate that in to the opportunity. And you'll notice here in this table, there's also a column with owner ID, just like in the opportunities table. However, this means something different in the company table. In many sales teams, you have a sort of global account executive who manages the relationship with the account as a whole. And then they may have a team of people, of salespeople who work on individual sales opportunities within that company. And so an interesting analysis to do may be to compare in what proportion of opportunities is the salesperson also the account manager. And so doing that comparison would require you to compare every row in this table with every row of owner ID in wherever it went in this table here. And so what that means is performing a row-level join across these two tables. Now, in PowerPoint, I told you that the purpose of relationships is aggregate joins. But now we've encountered a scenario where we want to do a row-level join, but also have aggregate joins at the same time. This is something that's not possible today with data blending. But with the new data model, you can have it all. Yes. So what's even better is that it's very easy. So to perform a row-level join across those two tables, all I need to do is create a simple calculation comparing the salesperson in both of those tables. So I'll just reference the owner ID, and when that is equal in both of these tables, this means that the account manager is also the opportunity manager. And so watch where this calculation appears in the schema viewer when I save it. In this case, it's not been parented with any table because it's crossing multiple tables. It's not appending a column to a table, it's like creating a new table on the fly. And so that gets added down here outside of all tables in the neutral zone. So now let's go and look at this, and we'll split up our number of opportunities. So using that count of opportunity table, and then the count of the companies as well. And you see what just happened there when I brought in the companies? Let me just go back. There were 2 rows in my viz, and then I dragged in company, and it actually added a row to my viz. So this is something that's quite different about the new data model, is you can actually change the records that are shown in your visualization as you add new fields. So what happened before was we were only showing, we were interjoining to the opportunities table. Whereas when I added in the count of company, we're now left joining to the company table, and that allows us to see this very interesting fact here, which is that there are 41 companies that have no associated opportunities at all. And so that null value is actually very interesting. It presents an interesting sales opportunity. Now we can also do aggregate calculations across the different tables in the same way as you would in Tableau today. So if I wanted to calculate a ratio of number of opportunities per company, I can simply drag and drop these calculations like normal Tableau. And so this is now also giving quite an interesting insight. What this tells you here is that there are lots more opportunities within a single company when the global account manager is also managing the individual opportunities. And so this bar chart really says delegation is bad. Perhaps that's not true on real data. The point here is to show you that a lot of interesting analysis is actually looking at the intersection of tables and what matches versus what doesn't match. And that type of analysis is something that's very easy with the data model enhancements. All right, so we've looked at row-level joins and aggregate joins across different tables. Now let's take a look at LOD expressions. So in this company table, you'll note that it doesn't have a field telling you when the company was acquired as a customer. And that may be an interesting field to add to the data source. The way that you can calculate the acquisition date of the account is by looking at the close date for the first opportunity that was 1. So we need to basically reach into the opportunities table and grab that data and then aggregate it back up to a company level. So in LOD expressions, what that looks like is we first want to identify the close date of the first one opportunity. So I'd calculate the first by taking the minimum of this row-level calculation. But then I want the minimum to be calculated at the company level. And so I'm going to go and fix this to the company ID here. I need to add a colon. And that is going to be our acquisition date. So where do you think this is going to show up in the schema viewer? It's using company ID from the company table, close dates, and 1 from the opportunities table. So raise your hand if you think it's going to end up in the neutral zone. Okay, raise your hand if you think it's coming in the company table and in the opportunities table. All right, good guess. So this is going to land in the company table. And the reason is because you can think of it like appending a column to the company table because we've fixed this at the company ID level of detail. Now, let me show you what happens if we instead fixed it to the company ID from the opportunity table here. Now think about, where is this going to land? Who thinks it's going to the company table? To the opportunities table? Yay! I mean, I didn't give away the answer at all. Never mind. All right, and so here it is now in the opportunities table. And so we will always be grouping your fields with the table that is at the level of detail of the calculation. So what that means for how you author data sources is it's probably best to keep the tables, to keep the fields grouped by tables, because there's actually some implications for how we query the data that's easier to understand if the data is grouped by table. All right, and so now if we were to look at the number of companies by acquisition date, we're again seeing this interesting null value that tells you there's 54 companies that you have some level of relationship with, but have never made a purchase. All right, so we've looked at row-level calcs, LOD expressions, and now let's take a look at aggregate calculations. So an interesting type of analysis you may want to do on this data source is looking at the win rate by product. So win rate tells you the percentage of opportunities that are won for each product. And so the way that you would calculate that today, we basically just need to look at this one field and then count the opportunities. So let me go create a calculation here. What we want to do is count, so give a 1 to the opportunities that are won, and 0s to the ones that are not won. And then I'm going to sum that up, and then we want to divide it by the total number of opportunities. And so in Tableau today, in a flat table data source, you would often divide it by the sum of the number of records. But the number of records no longer exists in a multi-table data source. We've replaced that instead with these automatically generated count fields. So if I drag this in, it's now going to, the count of the table is equivalent to sum of number of records. And so this is now going to give the win rate. All right, I'm going to hit apply. I want you guys to guess, where is this going to land in the schema viewer? You'll note in this case, I'm only including fields from the opportunity table. So who thinks this is going to the opportunities table? And who thinks it's going to the neutral zone? And who has no idea? All right, so this is going to land, in the neutral zone. And that's because it's an aggregate calculation. Aggregate calculations have an undefined level of detail. The LOD is determined in the visualization based on the combination of dimensions in the viz. And so that is why it is landing in the neutral zone. So let me grab the win rate now, and then we can break that down by products. So for example, in this visualization, the win rate is not at the opportunities level of detail. It's rather at the opportunity products level of detail. And I should filter these to just the ones that are closed, which gives a less pessimistic view of the world. There we go. All right, so we've looked now at the win rate by product. We also previously looked at some analysis that showed control boards are only 25% of the value of the orders they're on. What if we were to combine those two ideas? And so what if you wanted to know where your win rate is high, or for which combinations of products your win rate is highest? So in that case, that type of analysis requires doing comparisons across data that lives in different rows. If you think about how your data is structured, you have the opportunity ID and then a row per product. And so to know which products exist on the same opportunity, you have to do a cross-row comparison. And so relating the table, or just kind of self-joining the table, is one way that you can do that type of cross-row analysis. So I'm going to go back to the data source tab and take the opportunity products table and then just relate it into the model on a second time. And so what's happening here is opportunity products is now related to opportunity products on opportunity ID. And so when I use a combination of fields from both of those tables in the viz, it joins at the opportunity level of detail, producing a comparison of every row in one table with every row in the other table. So what that allows you to do, if I go back to the sheet here, is very simply just drag the second products into the visualization. And what this now shows you is that for towers, the win rate is highest when it's sold alongside installation. And that analysis was extremely easy. I just had to relate in the table a second time and drag in the second products field. Now, some of you may be wondering, was that analysis possible with joins? It is. You can always do things with joins. So let's look at the exact same visualization built on a joined data source. And again, you can see that this is joined because all of the dimensions are grouped together and all of the measures are grouped together. So just believe me that the numbers in this visualization are identical to the numbers in the other visualization. The challenge is that I've created a purpose-built data source that can only be used for this viz and maybe 2 other things. But this data source cannot be used for general purpose analysis. Now let me show you why. If I drag in the total opportunity amount, it's 86 million. You'll recall it's actually 13 million. And so this has caused 2 times the replication because I joined in that opportunity products table twice. So let me just go through and summarize what we've seen in this last section here. So first thing we looked at was that relationships, while they are designed for the purpose of aggregate joins, they allow you to do row-level joins if you use row-level calcs across the related table. You can continue, if you want to just append columns to one of your logical tables, you can do that through joins. We looked at how calculations appear in the schema viewer, which means if you are consuming a data source that someone else built, you can understand the level of detail of that calculation simply by where it's appearing in the schema viewer. We're replacing the sum of number of records with a count of the table for every table in your data source. And then finally, we saw how you can use self-relationships, relating the table into the model multiple times, to be able to do analysis across rows in the same table. So now we're going to look at another huge benefit of the new data model, which is the ability to do analysis across tables that have many-to-many relationships. So I'm just going to talk you through the conceptual model of this data source before we go and do anything in Tableau. So we're looking at sales opportunities. The opportunities are within, the customers are companies. And so one company can have multiple opportunities. And then within the customer account, there are individual people, known as contacts, who the salesperson has relationships in order to move the sale forward. And so each company has many people that the salesperson interacts with. And then the marketing team runs marketing campaigns targeting each of these individual contacts. And so there are multiple campaigns per contact, multiple contacts per company, and multiple opportunities per company as well. So bring this all together, and what this means is if you want to link your marketing and your sales data to understand the effectiveness of your marketing campaigns, you can't really uniquely trace through a campaign to a sale. It's an indirect association where a person engages with a campaign, that person belongs to a company that purchased an opportunity, and therefore maybe that campaign in some way had some impact on the opportunity. And this is the challenge of marketing attribution, among other similar scenarios. So if you were to just join these 4 tables together, it would cause a huge data explosion with many opportunities and many campaigns per company. And so now we can analyze this data much easier with relationships. Let me show you. So I'm going to go back to our data source here, and now I want to add in those 2 more tables. So the customer contact, the individual person, and then the campaigns that they're targeted with. So let me bring in the contacts table here, and then the marketing campaigns. And so we're now going to do analysis across campaigns and opportunities that are 3 degrees removed. So recall with data blending, you could not do data blending across tables that have 3 degrees of removal. All right, so let's go And now the analysis that we want to do is to look at the win rate by marketing campaign. So I'm going to take that same calculation that we were using before and then break it down by the campaign name. Here we go. And so now we can see which marketing campaign is happening to people who work for companies that have a high success rate in their opportunity conversion. That's what this visualization is saying. So then you may also want to know, are we doing a lot of that? Are there lots of opportunities where that interaction is happening? So I'll bring in the count of opportunities here, and then perhaps convert this to a scatter plot. And what you see here is that customer conferences are way out there. They're happening a lot, and they are associated with a high win rate. So that's the type of analysis that you can now do. I haven't done anything. The experience is identical in Tableau. I'm simply dragging and dropping fields as normal, but I'm doing analysis that wouldn't have been possible before without an immense amount of data preparation. So let me show you what is mysteriously happening behind the scenes here with Tableau. Who has seen the performance recorder before? All right, so the performance recorder allows you to capture what's happening in Tableau, including the queries that are getting sent to the database. So I'm going to turn that on and then just refresh this here. And so that will have run a query. I can stop the performance recording. So at any point in time, if you're like, what is Tableau doing? This thing is magic. You can always come and look here at the SQL that is being generated by Tableau. So let me just grab this query here. I'm going to paste it into SQL Server. And so all Tableau is doing here is generating this query as I'm dragging and dropping fields. There's a common misconception that Tableau is a visualization tool. It is really not. It is a SQL generation interface. And that's what we're doing with the data model, is we're taking those drag and drop interactions, and the SQL that you used to have to go to a DBA and say, hey, can you build me a table? Can you build me a view? Tableau is now generating that table or that view for you automatically on the fly. You'll see that this gives exactly the same results that we got in the scatter plot. And so that is at the core what the data model is doing, is much more enhanced SQL generation. All right, so I'm going to just go through and now kind of talk a little bit more conceptually about what does this mean for your company, for the people in your company, for the tasks that they're working on, the roles that they're accomplishing. So today there's sort of this division between IT and analysts in many of our customer accounts, where IT is managing this huge pipeline on the back end, accessing the data in the source system, securing the data, curating and making available all of the data assets in your organization. And one of the things where we're seeing a huge bottleneck in IT departments is in building views. Analysts are sort of working in the very last mile, doing some basic analysis and presentation, but fundamentally, anytime an analyst encounters a question that is a little bit more complex or that requires combining data that doesn't exist together, they'll have to go and submit a request to an IT person to build a view, and this is inefficient, and it's bad for everyone. It slows down the analyst, and it's not what IT wants to be doing either. So last year, we released Tableau Prep, where with that, we said, well, we'll give you this tool where the analysts can build their own tables very easily through drag and drop. So that gave them a little bit more access. But now what we're saying with the new data model is, in a lot of cases, that process of creating a table shouldn't need to exist. Like, we should be able to just generate that table for you on the fly automatically through drag and drop. And so that's what the data model does. It lets you define up front how the tables are related so that Tableau can just automatically generate that table for you on the fly. And so we're really allowing the analyst now to own a lot more of the analytic process. And this is better for everyone because data preparation, data modeling requires domain expertise. You need to know the question you're trying to answer in order to know what table to build or how to model the data. And so now we're putting that power in the hands of the analyst while IT can focus their technical expertise on more strategic enterprise-wide projects. So I'm just going to end off here by summarizing the key benefits of the new data model. One is that we're radically simplifying the process of data modeling through these contextual automatic joins, many-to-many relationships, and things that previously required a lot of upfront preparation. We're making analytics much more intuitive with automatic level of detail, by keeping the full domains, and a number of other nice semantics improvements with the data model. We're allowing you to create much more efficient data sources where we only query what is in use in your visualization. There's fewer joins, fewer calculations, because a lot of that logic can now be automatically generated on the fly by Tableau. Another benefit that I have forgot to mention up front is it also enables faster extract creation. So we see a lot of customers where their database is a bottleneck, they're executing 20 joins in their extract refresh process. Well, now you can create a model where each of those tables is imported individually, and that will help speed up your extract creation process. And then finally, fewer data sources to maintain, which is going to reduce the maintenance and allow you to bring together disparate domains like we just saw here, bringing together sales and marketing data. So with that, I'd like to invite you all to join our pre-release program, prerelease.tableau.com, and we'd love to hear your feedback on what you think. We'd love to engage in workshops with you. Like we are, I'm not just saying this, this is true. We will set up like 4-hour workshops with customers and come on site and test out the data model on their data. And so if that's something of interest to you, here's my contact details. Please reach out, and yeah, we'd really love to hear your thoughts. So thank you so much, and yeah, hope to speak with many of you soon.